Right, we will start shortly. I'll stop sharing the QR code, yeah. Okay, let me share my screen. You guys can see my screen?
Yes, can see the screen.
All right. So today we will discuss two tutorial since we did not discuss tutorial 7 yet, and then we will discuss tutorial 8, which Dr. Zuzana uh, buat lecture last week kan. Alright, so we look into tutorial 7. I hope you guys have tried to do this tutorial. So it's about discrete probability distribution. So the first questions, for a group of men, the probability distribution for number X who live through the next year is given in in this in this table. Find its mean and standard deviations. So this is probability distributions. So when you look at the lecture notes, the method kan how to calculate the means and these are the formulas to calculate probability distribution, the means, the variance, and the standard deviations. So what you need to do is you need to expand the table. So we have x and px here, right? So you expand the table so that you have x times p, x times p, and x squared times p. Why? Because you will need it in this SketchUp. Because later on in standard deviations, you need x squared times px, and also in the mean, you need x times px. So it's better for you to construct, to extend the table like this. Ada x times px and x squared times px. So later on, you will just use the values here. So what you need is, you just take the formula here for mean. So mean is summation of x times px. So directly, you can get it from this table here. So your mean is 3.9598, and the standard deviations, the standard and of the variance, so the variance will be using this formula here lah. Okay, so you just substitute the summation of x squared times px minus with square of mean. So yang ni mean tadi, both you can get from the table. Yep. Sekejap ya. Okay. All right, and then as for the standard deviations, you know that the standard deviation is actually a square root of the variance. So what you need to do is you just square root the variance here, and you will get your standard deviations jadi 0.2010. All right. Question number 2. Okay. In a study of brand recognition of Samsung, groups of 5 consumers are interviewed. If X is the number of people in the group who recognize the Samsung brand name, then X can be 0, 1, 2, 3. Means that 0 means that none of the interviewers, none of the people recognize Samsung brand. 1 means only one people recognize, 2 means 2 people, and 3 means 3 people, and so on lah, 4, 5. Okay, and the probability that they get from this probability distribution is you get 0.0.1, you have 0.0016, 0.125, and 0.0532, and 0. And so on lah. These are all the probability for all x kan. So now, from this information, is this a valid probability distributions? Okay, how do you answer this? Is you need to sum all the probability here, px, the summations, and you will get 0.8864, which is, it does not equal to 1, bukan 0. Does not equal to 1, because you know that supposedly the summation of probability have to be equal to 1, right? So if in this case the summation of probability does not equal to 1, so means that it is not a valid probability distributions. Yeah. Okay, so far?
Okay. So far.
Okay, question 1 and 2, okay. All right, question 3. When you give a casino $5 for a bet on, you give a casino $5 for a bet, and there is an opportunity, the probability is 251 over 495. So this is the probability of winning, right? Or we lose. Okay, this is the probability for losing. Okay, lose $5. So the probability of winning is 244 over 495. So this is the probability of net gain lah, winning lah, right? So if you win casino gives you $5 and you get to keep your $5 bet. So the net gain is $5. Okay, what is your expected value in the long run? How much do you lose for each dollar bet? Okay, so now you have two situations, right? It's whether you losing or you winning, betul? And the probability of losing is two. Zoom a little bit. So the probability of winning is 251 over 495. This is probability of losing. And probability of winning from the questions now is 244 over 495. Right? So now you extend the table to have x times px. Why? Because the expected value, the formula for expected value, I think it's here. Let me go to the lecture. The formula for expected value is summation of x times px. So that's why you extend the table here to x times px. So your expected value, this question asks you to calculate the expected value. So the expected value will be the summation of x times px, which is negative 7 cents. Okay, so means that on average, you will lose 7 cents each time you play a $5 bet. So for every dollar bet, you will lose. Kalau untuk kira for $1, for $5 is you lose 7 cents. If for $1, so you just divide lah 7 times divide with 5. So for $1, you will lose around negative 1.4 cents. Macam tu. Okay, very straightforward. Okay, you look at number 4. This is also probability distribution. Okay, mention here, this is a list of probability distributions. Let the random variable x represent a number of girls in a family of 4 children. Kita ada 4 children. 1, 2, 3, 4. Construct a table describing the list of probability distribution, then find the means and the deviations. Okay, here list different possible outcomes. This is what we do first. We list out all the possible outcomes. Kita ada 4 children. So we list out lah anak pertama girl, and then you list out all the possible combinations. Okay. And the question here is it unusual for a family of 4 to consist of 4 girls? And that is the question that we need to answer. So first, dia bagi hint dekat sini. First, you list down the combinations, right? The different possibilities. Okay, so this is the what you have lah. You have 4 children, so ada combination of girls. First daughter, first child girl, second child boy ke. So you list out all the probabilities. The outcomes. Okay, once you have this, what you need to do is you need to construct a probability distribution table. So you tahu kalau probability distribution, you're gonna have x and you're gonna have px, right? You're gonna have a probability for getting the x. Okay, so of course the first one is 0. 0 means probability for not getting all apa ni, no boys kan, macam tu. So you just calculate. So you kira dekat sini lah. Is how many combinations do you have? You have 16, right? So means that 0. So probability for getting 0 boys, for example, you have 1 kan? So 1 over 16. So you're gonna have 0.0625. Similarly, as this one, probability of getting one girl. So you can kira lah how many outcomes there for one girls. Okay, kira. So you divide with 16. So you get the probability. So same as the other. Yeah, this one is all girls kan? So all girls also satu kan? So 1 over 16 as well. So it's 0.025. So once you have this probability distribution table like this, and you need to calculate all these mean, standard deviation, kan? Of course, you need to, like question number 1 just now, so you need to expand the table to x times px and x squared times px because you need to calculate the mean after this. So, what you need to do is you calculate lah using the formula for mean. Mean is summation of x times px. So you just get the value here, summation of x times px, which is 2. And the variance, which is x times px, x squared times px minus mean square. So x times px is ni lah. Yeah. Just 5 minus mean square. So you get equal to 1. And your standard deviations is square root of variance. So equals to 1. Okay. So now when you look at the questions, the second question, is it unusual for a family of 4 children to consist of 4 girls? Is it unusual? So you have to look at 4 girls punya probability lah. So when you get 4 girls, the probability is 0.0625. Okay. So 0.0625. So you have to compare to you have the unusual and usual punya tu kan. When it is more than 0.05, so we can say that it is not unusual for a family of 4 children to have all girls. Macam itulah. So you just compare with 0.05. Okay. Now, question number 5. I think this one is already binomial. Okay, we look at binomial, yeah. Yes. Okay, an author purchased a slot machine that is configured so that there is 1/2000 probability of winning any jackpot. So you look at the requirement of the binomial probability distribution. So, okay, first one is the procedure has a fixed number of trials. The trials must be independent. Each trials must have 2 categories, success and failure. So in this case, winning or losing lah, kan? And then the probability of success remain the same in all trials. So mentioned here, there is a 1/2000 probability of winning. So meaning that there is only one probability for winning, 1/2000 probability. Okay. So suppose that a guest claimed that he played the slot machine 5 times and hit the jackpot twice. Okay, A, find the probability of exactly 2 jackpot in 5 trials. So kita kena tengok sini lah how you calculate this lah. Right? Alright, so this you're gonna use the binomial probability distribution formula, yeah? So in this case, you know that n is equal to 5, kan? Dia cakap 5 times tadi, kan? So n is equal to 5 and the probability of winnings is 1/2000. Nampak tak? Okay, 1/2000. So the probability of winning is 0.0005. So the first question is exactly, apa tadi dia minta? Find the probability of exactly 2 jackpots in 5 trials. 2 jackpot in 5 trials. So means that we want to calculate the probability x equal to 2. 2 jackpots. So you know that you want to calculate probability of x equal to 2. So you just use this formula here. Guna formula ni and substitute all the values. So substitute n, substitute r, semua kan. Okay. You know that n is number of trials, r is the number of success among n trials. So this is your r kan? R is equal to 2. So you just substitute, so you calculate, so you will get A equals to 0.000025. Okay? And the second question, find the probability of at least 2 jackpots in 5 trials. At least 2 jackpots. So meaning that more than or equal to 2. So x is more than or equal to 2. Okay. So in order for you to calculate this, you kena tolak 1 minus anything that is less than 2, right? Because you want the probability of getting at least 2 and more. So in order for you to calculate that, so you just minus by 1. So 1 minus anything less than 2, you will get probability of x equal to 2 and more. Can? So when you have this, 1 minus px less than 2, so you will know already. So 1 minus anything less than 2, so it's either x equals to 0 plus with x equal to 1. So you minus anything less than 2 lah. Alright. So once you have this, once you know this formula here, so you know already what to do kan? So 1 and then this one x equal to 0. So you just use this formula here and substitute r equals to 0 lah. And then n equals to 5 and so on lah. The probability will be the same lah. The PQ kan will be the same. And then plus with x equal to 1 pula. So you just substitute again the formula here and you letak r equals to 1. So you calculate. So you have 1 minus this and this. Okay, this is probability equal to 0. This is probability equals to 1. So you get this probability for at least two, for getting at least two jackpots, which is 0.000002497. Okay. So question C, does the guest claim of two jackpots in five trials seems valid? Explain. So the answer will be no, because the probability of getting two jackpots is less than 0.05. So it will be unusual because it is less than 0.05. It will be unusual to hit two jackpots. If the machine is functioning as it's supposed to be, either guest is not telling the truth or it is really extremely event occur. Okay. So you have to, whenever you want to check the unusual and usual part, you have to compare with 0.05. Yeah. Okay. Number 5. Okay, semua?
Yeah, okay.
Okay. Are you still with me? All right. So now number 6. Number 6, in a test of Microsoft method of gender selection, 51 babies are born to couples trying to have baby boys, and 39 of those babies are boys. Okay, kita ada 51 babies are born and 39 babies are boys. So if the gender selection method has no effect, boys and girls are equally likely. So this one, ini dia bagi tahu probability ni. For getting boys and girls are equally likely. So means that the probability for getting either one is equal, sama lah. So it's 0.5, right? And the number of bukan trial lah, the babies born is n equals to 51, right? So now, if the gender selection method has no effect and equally likely, so there's our probability is now, find the mean and standard deviations. Find the mean and the standard deviation for the number of boys born in a group of 51. So, yang ini, we just look at the formula for mean and variance for binomial. Yeah. So this is the formula. Mean is equals to n times p. Variance is equal to n times p times q, and standard deviation is the square root of variance lah. So our mean is n times p, so you just multiply. So you get 25.5. This is the mean. And for the variance is n times p times q. So just stop that out je, and you will get 12.75. And as for the standard deviation, square root of the variance. So you just square root kan lah, and you will get 3.571. Okay. So now, is the result of 39 boys unusual? So you need to calculate the unusual values kan. I think ada dekat sini. Here is the minimum and the maximum of usual values. So we need to have a range lah. It's actually a plus minus lah. Okay, the mean plus minus two standard deviations. That will be a range of unusual. Okay. So anything that lies outside these limits is unusual. So what you need to do is you just substitute all the values. Kita dah kirakan mean and the standard deviations. What you need to do is just substitute all the values and you calculate the the limits, yeah, the interval. So it is in between. Yang ni kena kira lah. 18 plus 4, 18 plus 4 plus 32.6 and 18 plus 4 minus 32.6. So you calculate and you see you need to check whether 39 is within or outside the interval. So in this case, 39 is outside the interval. So we can say that it would be unusual number of boy birth. Okay, macam tu. So first, you need to calculate the interval of the the range rule of thumb of unusual cases. So kita ada interval. So and see whether the numbers that we need to check to within or outside the interval. If it's outside the interval, then we can say it is unusual numbers. Yeah, it is unusual result lah. All right. That is number 6. Okay, not so far. So that is binomial, binomial. Number 7. Number 7, Kiki found that in 1 month, in 30 days lah, she made 47 cell phones calls which were distributed as follows. So no calls were made on 17 days, 1 call was made on each of 7 days, 3 calls were made on each of 2 days, 4 calls were made on each of 2 days, 12 calls were made on 1 day, and 14 were made on 1 day. Okay, these are the calls that dia buat lah. Okay, we look at, sorry. Okay, now the question that we need to answer is A, find the mean number of calls per day. Okay, this one we use Poisson probability distributions. So you look at the formula for the Poisson formula dia. Okay, the mean for Poisson probability, Poisson distributions is the number of to divide with the total number of trials lah. In this case, Katie within 1 month, within 30 days, dia buat call 47 calls. So the interval, the average of the calling, the mean tu lah, the average is 47 over 30. Yeah, so this is the mean, 47 over 30. So look at B, use the Poisson distributions. I mentioned here, use the Poisson distribution to find the probability of no calls on a day and compare the result to the actual relative frequency for the number of days with no calls. So we use Poisson to calculate first. So using Poisson, where is there's no call, so x equals to 0, you need to use the where is the this is the formula for probability for Poisson, yeah? So we need to calculate using this. So the question B is to find probability where there's no call. So x equals to 0. So what you need to do is just substitute lah. Kita dah tahu kan what is mean, we know what's mean, and E is the exponent lah. R is number of calls lah. So R is 0. So we just calculate, we get 0.209. So we want to compare with the actual relative frequency. Let's say we don't use Poisson, we use the real data, kan? We use the real data given and you just divide with how many days where there's no calls, kan? So we look at the question here. We look at the question here. No calls were made on 17 days. So that's how you calculate relative frequency. So within 30 days, only 17 days no calls were made. So 17 divide with 30. So you get 0.567. So when you compare these two, it's supposed to be equal now. Bukan equal or almost the same. When you look at this, it's not the same, right? So the Poisson probably does not compare favorably with the actual relative frequency. Dia jauh kan? It's not the same. So dia cannot be compared. Okay. Later on I will explain why. Okay. So C, use the Poisson distribution to find probability of 1 call a day. So 1 call a day. So now our R is equal to 1 now. Probability of 1. Ini substitute R equals to 1. Okay, you calculate. This is using Poisson. Now for the relative frequency, berapa hari dia buat 1 call sahaja. So for 1 call, dia buat dalam 7 days. So 7 out of 30. So 7 out of 30, when you calculate, is 0.233. When you compare these two here, Dia tak sama kan? It also not probably with the actual relative frequency. Okay. So now D, based on the preceding result, does it appear that Kiki cell phones made in a day fit the Poisson distribution reasonably well? Whether in this case, whether kalau you compare question B and C just now, when you compare with the relative frequency, whether you can decide already whether Poisson distribution is suitable for this type of case. Okay, in this case you can see that when you use Poisson distributions and when you use relative frequency, both result give macam banyak beza kan. So in this case means that the actual number of calls made by caller does not fit the Poisson distribution. So kita tak boleh guna Poisson distribution in this type of case. Why? Because calls are not made randomly and independent of each other. When you look at the requirement of Poisson distribution, the requirement must be random. The occurrence must be random and must be independent. Okay. Ini yang tak ada dalam soalan ni. Why? Because Katie is the one who decide how many calls yang dia nak buat in each day. See? It is not random. It's someone decide to make, kalau dia nak buat call hari ni, dia call hari ni. Kalau tak, tomorrow. How many calls dia nak buat tomorrow. So, she's the one who decide. So, this occurrence does not seem to be random. So, that's why Poisson distribution tak sesuai lah untuk this situation, untuk calculate this probability in these situations lah, because it is not random, it is not independent, right? That's why. Okay, faham question 7, you guys okay?
Okay, madam.
Okay. All right. So question 8. Okay. Currently, an average of 7 residents of village Westport, population of 760, dies each year. So find the mean number of deaths per day. Okay. Oh, ini salah ni. Mean number of deaths per day. Sekejap. Supposed to be 13. Yeah. Sure. Let me see. Okay. So this not 3 ni have to be divided with each year kan. So year we have we consider we have 365 death death pula per year. Let's see. Yeah. So this is supposed to be 7 divided with 365 because of per year. So that's why you get 0.019 as the mean. Yeah. Bukan 3 dia 365. Right? Now, question B. Okay, mean kita just divide lah. We have 7 days per year. So 7 divided with 365. And B, find the probability that on a given day, there are no deaths. Okay, no death. So means that R is equal to 0. Okay, so R is equal to 0. So you just substitute into the formula for Poisson. So you get this probability. That is question B. Question C, similar, but you need to calculate the probability on a given day there is one death. So R is equal to 1. Substitute inside and you get this. Very straightforward. You just substitute into the formula. Okay, and for D, find the probability on a given day there is more than one death. So more than one death, more than or more or equals to 1 lah. So macam tadi lah, macam question I think 7 just now, is 1 minus anything less than 1, which is x equals to 0 and x equals to 1, which is you already calculate in question A, B, and C. So you get probability of getting more or equal to one death is equal to 0.002. Macam tu je. Okay, that is how you answer this question here. Okay, let's say for this case, when you talk about death, kalau you nak tengok why we use poison for this case, is because it is random and it is independent. Because death is, we don't know kan bila death can happen, how many death can happen per year. It is very random and very independent. So that's why we can use poison distribution for this case. That's why it fits more lah compared to question 7 just now. The calls are not made random and it's not independent, yeah, because it depends on that Katie kan they could call. That's why question 8 is okay for you to use poison but not question 7. Okay, now the last question for tutorial 7. Vehicle passed through a junction on a busy road at an average rate of 300 per hour. Okay, 300 per hour. This average rate of 300 per hour. Okay, find the probability that none passes in a given minute. So, of course, in Poisson distribution, you need to calculate the mean first. Sebab dalam equation dia memang ada mean. So, you need to calculate the mean first. So, the mean is 300 per hour. So, 300 over 60 minutes, kan? So, it's equal to 5. So, question A, find probability that none passes in a given minute. So, none, which means R is equal to 0. So, you just substitute. So, you will get this probability for question A. For question B, what is the expected numbers passing in 2 minutes? So mean times with, ada formula dia. Sekejap. Means times with, is there a formula in the x times x? So means times with this supposed to be because of these 2 minutes here. So within 60 minutes, you have five vehicle pass through, right? So in 2 minutes, so you just times 5 times with 2 minutes lah. So you get 10. So expected value for vehicles to pass through is 10 within 2 minutes, yeah? So now, find the probability that is expected value actually pass through in a given 3-minute period. So we have 10 kan, kita nak calculate the probability of this expected value to happen in a given 2 minutes. So we want to calculate the probability. So x, tadi kita kira expected value is 10. So now we want to calculate the probability of getting 10 vehicles. So x equals to 10. So this r lah. So r, so you just substitute, then you calculate, and you get the probability for getting 10 vehicles to pass through is equal to 0.12511. Okay, that's it for tutorial 7. You guys okay with tutorial 7? Let me stop sharing first. Lepas ni saya... So far okay. Okay. Wait, after this we will continue with... sekejap ya. Give me a few minutes to change. All right, you guys can see the screen?
Yes, can see the screen.
Okay, chapter 8. Chapter 8 is all about normal distributions. This is the basic of normal distributions. Later on, so you need to understand chapter 8, all the basic in chapter 8, in order for you to apply it in chapter 9, 10, and 11. Okay? Because here you learn how to refer to the table, kan? You learn how to refer to the Z table, the T table, and so on lah. All right? So now, question 1. Question 1, you guys already okay with how to refer to the Z table or not? If yes, then I will just provide answers to chapter 1. You guys okay already kan? Very straightforward lah Z table. Remember that Z table only gives you the result to the left, yeah? Left side. Dia akan give you result to the left side. So for example, question A here, when you want to find value for Z more than 1.85, so if you draw a bell shaped graph like this, Z 1.85, when you refer Z 1.85 in the table, it will gives you this area. But the question wants you to get Z more than 1.85. That's why you minus it with 1. That's one sebab the area of the below table is equal to 1. Remember that below graph, the area of below graph is actually the probability. So the total of the probability is equal to 1. So when you refer to the graph, it only gives you the probability to the left side. So whenever you want to find values that is for the right side, which is more than, Z more than something, then you need to minus by with 1 lah. Okay? Similar macam soalan 1 ni, that's why you minus dengan 1. You get this one, you directly get it from the table, 0.9678, you get it from the table. But you want this yellow shaded area here, so you have to minus by 1. Yeah? Same with question B, sama juga, because it's more than, so that's why you have to minus this side. This is the things that you can get from the table. This area here, you can get from the table. But you want the yellow shaded area here, so you have to minus with 1. Macam tu macam ini, less than negative 1.27, you can directly get from the Z table. Sebab dia on the left side. So Z table only gives you values on the left side, yeah? Okay, similar like D pun, D tak ada pula. Oh, terlepas pula D dekat sini. But never mind, you just refer to the table. You get Z less than negative 0.93. You get the answer directly from the table, 0.762 lah for D. For E, because it is in between, sama juga. Because it is in between, you see here, Z less than 0.35 or 0.175, which is here, right? So when you refer to the table, it gives you values from here to here. When you refer to Z net 1.75, it gives you all the area from here to here. Dia bagi semua. And then what you need to calculate in between je kan? You need to calculate in between here. Okay, so you have to minus anything that you get from here lah. So that's why 1.75 minus with 0.35. Then you get this yellow area here. Okay. Sama juga macam ni lah. 0.35 minus with 1.85. Then you get the yellow area here. Okay. Itu semua okay kan? So make sure you know how to look at the table. Because yang tu tak boleh ada masalah lagi when you enter chapter 9 and chapter 10, chapter 11. Okay? Make sure you know how to read the table. Kalau ada problem, you need to ask your friend how to do it, or you can ask me how to look at the table. Okay? Okay, find the value of A. Let's say given to you the probability and you need to find the value of A. Macam mana? Okay. Kalau remember that this value here, 0.6198 here, is the value that you can find in the body of the table. Table dia macam ni kan? This is Z. Ni yang semua value all the probability. So when you have something like this, 0.61, so you have to find 0.618 in the body of the table. The body of the table, and you can get your your Z value is equal to 0.305 macam itulah. Okay. So for B, more than A, so you know that kalau more than A, you cannot just get directly from the table kan? Because it's more than. So you have to try, tukar dia bentuk dia jadi 1 minus Z less than A. So you get 0.7 here, and then you transfer lah 1 minus 2, and you get 0.2182. So how do you get the Z? Is you need to find 0.2182 from the body of the tables now. Baru you cari apa value Z there. So in this case, the Z value is negative 0.775. Okay? So you need to know where to look at this table. Kalau area, kalau probability, so you need to look at the body of the table. Bukan dekat Z score punya value tu. It's different, yeah? Okay. Okay, X is a normally distributed variable with mean equal to 30 and standard deviation equals to 4. Okay, find the following. So when you refer to the normal distribution punya lecture, you will have a formula to calculate Z. Where is it? Sekejap, I go through. Anyhow, learn how to look at this Z table. Here it is. Conversion formula. You have this conversion formula here. So this is conversion formula. So you apply it in this question here. If X, you need to change it to Z. So you just substitute lah. Substitute semua dekat sini. So I think this one is quite easy lah. Okay, you substitute 40 minus 30 divided with the standard deviations. It's all given here. The mean and the standard deviations. So you have your Z equals to 2.5. So once you have that Z equals to 2.5 less than, so you can directly look into the table. So from the table, you have your values, the areas on the left of 2.5 is 0.9938. Similarly as B and C, macam tu juga. So you just use the conversion formula to calculate. So in this case, you want it in between more than negative 2.25. So more than kan, kalau kita more than, we have to minus with 1 kan. So 1 minus with Z score less than negative 2.25, which is you will get 0.0012, and your answer will be 0.9878. And for question C, in between 30 and 35, you can kira Z for both sides, 30 and 35. For 30, your Z is equal to 0. For 35, your Z is equal to 1.25. So you want to find this value actually, probability of 0 to 1.25. So which means that you have to minus area from 1.25 minus with area Z equals to 0. So you will have you'll be like this lah. Kalau you lukis dia punya graph kan, here will be 0, here will be 1.25. So you want this area here. So what you do is Z equals to 125 minus with Z equals to 0 from the table. So you will have 0.3944. Okay, that is for question C. Okay. Now, assume that the adults have IQ scores that are normally distributed. So, mean is 100, standard deviation is 5. Okay, find the probability that a randomly selected adult has IQ that is less than 115. So, X less than 115. What you need to do is conversion formula. And you need to find probability of Z less than 10. Yang ini boleh direct because of less than, you can directly refer to the table. So you get 0.8413. And then greater than, B is find X greater than 131.5. Convert first to Z. And then more than, tengok more than ni, of course you need to minus with 1. Then this one you get from the table lah. So 1 minus 0.9821 equal to 0.0179. And for C, we want to find in between 90 and 110. Of course, convert dululah macam biasa using this formula. And by looking at this, kalau lukis kan, here would be negative 0.67. Here would be 0.67. So you want this area here. So probability of getting Z 0.0 equals to 0, Z less than 0.67 minus yang ini, yang besar minus yang kecil lah. So you get this area here. So minus Z less than negative 0.67. This one you get from the table, and you just minus. Okay. Sama juga dengan D. Sama. Convert first. And then minus, you get 0.1596. Okay or not? And question E is about quartile, I think, percentile. So, we want to find the probability P30, which is the IQ score separating bottom 30% from the top 70%. Okay, so our probability is we want it to be the probability, the percentile is 0.30, right? So our area is 0.30. So you look at the body of the table, you look at it because this is the area, okay, the probability. So you look at the body of the table and find the closest to 0.3s. Okay, so the closest entry that you can find from the table is 0.92981. So you kena tengok lah. Once you find it in the body macam ni kan, this is Z, this is the area. So once you find this value here, you need to refer lah what is the Z value. So you refer to the Z value from the table is negative 0.53. Okay. And the score corresponding to this percentile, you tukar balik pergi ke the score using this conversion family formula as well, but you manipulate it lah because you already have Z, but you want to know the X. So you manipulate. So X equals to 100 minus 0.53 over 15. So you get your X equals to 92.1. Similarly, in question 5 and question F and G, F kita nak kira first quartile, which is P25, okay, percentile 25. So the area is 0.25. So the closest in the body of the table, in this area, body of the table, is 0.2514. Okay. So refer, once you've studied, you jumpa and you refer to what's the value for the Z score is negative 0.67. So once you have this, you convert it to X using the conversion formula and you get your X equals to 89.95. Sama juga dengan G, is apa? Q3, which is 75 percentile, so 0.75. Cari yang closest is 0.7486, closest in the table. So you get your Z score is 0.67. And then you convert it to X, you get your X equal to 110.1. Okay, so far? Are you still with me? Okay. So make sure you know how to do and really understand chapter 8 before you can proceed with chapter 9. Okay, a soft drink machine is regulated so that it discharge an average of 7 liters. So average of, so this is your mean lah. This is your mean. This is your mean. So it is normally distributed and with a standard deviation of 0.5. So this is your standard deviation. So what proportion of jug will contain more than 7.8 liters? So more than 78 liters. So kita X dia 7.8 liters, more than 7.8 liters. So what you do is convert first. convert, and then cari. See more than, kena tolak satu lah, right? We have to minus by 1. So you will have your probability for getting x more than 7.8 is 0.0548. And as for B, what is the probability that jug selected will contain 6.7 and 7 point, between 6.7 and 7.3. So between 7, so kita kena convert dulu lah. Sama je cara tadi. Convert dulu and then we have to minus lah. Because we want the area in between only. So z less than 0.6 minus with z less than negative 0.6. So this is the value you get from the table. You just minus it and you get, and the probability in between 6.7 and 7.3 is 0.4514. Okay. And for C, the probability of getting X more than 8, macam biasa, convert dululah. Jadi Z more than 2. Okay. Okay, please bear in mind that if you have more than 2, let's say here is 2, right? Okay, this is the probability that you want. So know that probability of negative 2, the area, because normally distributed, so it is actually apa? Sama kan, both sides. So you can just refer to the negative point, apa tu, z equals z less than negative 2 from the table. So the area will be the same. So the probability will be the same. So it is equal to 0.0228. Yeah. So if 1,000 drinks are discharged, therefore you want to calculate out from the 1,000 drinks, so times with the probability, so you will get 23 jugs will likely overflow. Okay, that is for C. And for D, below what value do we get the smallest 25% of drink? So for the smallest 25% of drink, so the probability will be 25%. So the cumulative area is 0.25. Refer to the body of the table and see what's the value for Z. So the value for Z is negative 0.67. So you get it macam tadi kan soalan tadi. So you have the Z. Now you want to calculate the X. So still using the conversion formula. So you will get 6.67 liters. Okay, that is question 7. Okay, question 6. Sama. Ini you know the pattern already. You have mean, you have standard deviations. Yeah, you know that already for you to calculate the Z score. So find the probability lie in between 45 and 65. So you calculate, tukar dia, convert dia pergi Z, and then you calculate. I think I don't need to explain this anymore because the more or less the same. Yeah, how to calculate it. You have to convert it to Z score and then just refer to the table and then minus lah if needed. Okay. And like for this one, X more than 60, convert into Z and minus with 1 because more than. So you get this 0.9332. Okay. Stop me whenever you want to ask questions. Yeah. Okay, C. If the examination syndicate intends to pass 70% of the candidates taking the examination, find the lowest passing mark. So kita nak buat intends to pass 70% of the candidates. So the lowest passing mark will be 30%. So the cumulative area is 0.3. Macam tadi kan, 0.3. Find it in the body of the table and then get the value for Z for that value. And then convert it using conversion formula to find X. Once you have the Z, convert it into X. You get 69.7. Okay. Find the interquartile range of the distribution of marks. So interquartile, you know that interquartile is Q3 minus Q1, right? So it's P75 minus P25. So we have P75 is, Z 0.73. So you refer to the table, you give you Z value is 0.675. And for P25, which is 0.25, look at the body of the table and find what's the value for Z score, which is negative 0.675. 5. So now we want to calculate, this is x for 75, this is x for 25. X maksudnya yang inilah, you have to calculate the conversion, convert the z score back to the x value. Yeah, so this is the conversion for x 75, and this is the conversion for x 25. Okay, so you have the quartile, interquartile will be equal to 13.5. Okay, I proceed. If you don't stop me, I just proceed. Yeah. Okay. For a certain type of computers, the length of time between charges of battery is normally distributed means that we can use the normal distribution formula. So mean of 50 hours. So mean is 50 hours and standard deviation is 15 hours. John owns one of these computers and wants to know what is the probability that the length of time will be between 70 and 50. So dia nak cari probability of X pula. Probability of in between 50 and 70. Okay. So what is the first step when you have x like this? What is the first step? Is to change it to convert it to z. So convert it to z first. So ini conversion ini step untuk conversion for 50, and this is the step for conversion for 70. So you convert this to z first. Ini conversion dia. It will become 0 to 1.33. So once you have this, what you need to do is you refer to the table. So since you want the probability in between 0 to 1.33 only, so the area for 1.33 minus the area of 0. So you get this in between area. So this is what you get from the table, and then you just minus lah, and you will get in between of the probability of getting in between of 50 and 70 hours is 0.4082. Macam tu. Right? So now, question 8. Entry to a foreign university is determined by the country national test. The score on this are normally distributed. Okay, these are the things that you need to find lah. Mean 500, standard deviation 100. Okay. Aminah wants to be admitted to this university and she knows she must score better than at least 70% of the student who took the test. Aminah take the test and score 585. Will she be admitted to the university? Okay. Now we have 500 mean, we have standard deviation equals to 100, and Aminah gets 585, kan? Okay, now we want to calculate the Z score. So use conversion formula. So you can have Z score is equal to 0.85. These are the for Z score. The proportions of students who scored below 585 is given by, you refer to below less than lah. So you refer to the Z table for 0.85. So you will get 0.8023. So which is 80.23%. So which means that Aminah scored better than 80%, 80.23% of other students. Okay. Sedangkan for her to be admitted in the university, she only need to be score better than at least 70%. So now she scored better than 80%. So which means that she will be admitted to this university. Okay. All right. Question 9. Police uses a radar unit to measure speeds of cars on highway. The speeds are normally distributed. Mean 90, standard deviation 10. What is the probability that a car picked at random is traveling more than 100? So more than 100. Nampak X dekat sini, we cannot do anything. We have to convert to Z. So convert lah. Ini conversion process. This is the conversion process to Z. So more than 100, so will be more than 1. Okay, because Z is equal to 1 once you convert. And you just refer to the probability of Z less than -1 because the area is the same left and right, kan? Because it's symmetric. Then the bell shape is symmetric. So the probability is the same when you refer to the table is 0.1587. So the probability that the car selected randomly has a speed greater than 100 kilometers per hour is equal to 0.1587. Okay. Okay, number 10, let X be the score on nationwide mathematics test. Normally distributed, mean 80, standard deviation 10. Suppose May achieve 92 on this test. How many standard deviation was her mark above the mean? So which means that how many standard deviation was her mark above the mean. So ini mark dia kan, this is conversion formula actually. So the difference between her marks with the mean and how many standard deviation, that's why it's over standard deviation, yeah. So x minus mean divided with 10. So may achieve a grade of 1.2 standard deviation above the mean. Okay, that's how you calculate for question A. Find the proportion of students who achieve a higher mark than May. So we want to find students that will have a higher mark than May. So we know that the Z score for May is 1.2. So we want to find the probability of getting more than 1.2. Okay, so more than, so we have to minus with 1. So 1 minus 0.8849. This one you get from the table. And then you will get 0.1251. So which means it's around 12% of students achieve a higher mark than May. Okay, that is B. C. Suppose David achieve a grade of 1.8 standard deviation. So this will be Z for David, yeah. 1.8 standard deviation above the mean. What was his actual grade? Yang ni Z. So we want to find X. So we just use the conversion formula lah. This is our Z just now, yeah, 1.8. So you just substitute into the conversion formula, you get X equals to 98. So means that David punya markah is actually 98. Eh, oh, this is the last question. So until 10 question only, right? For tutorial 8, you guys pada 10, correct? Yeah. So any questions so far for tutorial 8? You guys understand chapter 8 clearly? All right. So make sure you guys know, you really understand chapter 8, yeah? Because later on, we're going to use all the basics in chapter 9, 10, and 11. In hypothesis testing, semua nanti, semua akan guna Z-score and on. Semua akan guna all the table for Z-table, and later on, you will learn how to look at into T-table as well. Okay? So tomorrow you're gonna have a mass lecture with Dr. Susanna as well. And next week since it is Gawai week, there will be no mass lecture next week. I will announce this again in the our telegram lah, our main telegram. There will be no mass lecture next week. So means that next week you only be using recorded videos in ELIP. So it will be asynchronous learning lah. But on Monday, our tutorial masih ada lagi. I think Monday okay sikit kan? Boleh lagi kan? Just in the morning. But on Friday, since it is Gawai, so we give you some times to cuti lah. Alright, so you don't have to attend any mass lecture. But on Monday tutorial, we still have class lah. Okay? Alright, if there's nothing else, we can stop here. I need to kejap. Ada lagi tak yang belum scan? Okay, let me share you the QR code one more time. All right. Okay, for the others, you can leave the session. All right, you can leave after you scan. All right, see you next week.